Yeah, so we're UMCF, and we have Marcelo, Malika, and then me as a team. And yeah, I'll hand it to Malika for a start. Is she here?
I don't know. I guess she's not here in the room right now.
Okay, then I'll go from my yeah, my study as well. Through the semester, I did one test study as part of the UMCF like software simulation, and I put focus on the impact of urban morphology on the urban heat island and also wind environment with Outdoor Plus. And just as an interest, like I was really interested to quantitatively examine how difference in urban morphology affects both urban heat and also wind simulation. And I decided to put focus on the Tokyo. Um, yes, and the goal and also result of this semester. Initially, the goal of this semester is like making and getting configuration 3D model of Tokyo, multiple cities with appropriate levels of details, and also test how different urban configuration affect the actual environment, like successfully run the simulation. And as a result, I developed a model of Tokyo with quite like appropriate level of details. However, the simulation didn't fully coverage and still is working on the process. So for the data set, I got GML5 data from a plot of Tokyo, which is like a government project, and it has all over the like a Tokyo 3D configuration. And I basically converted that GML file to open on Rhino by Grasshopper, and just by simplifying it, yeah, I got a data set for this case study. And moving into the process of the simulation, so there's so much problem on like making mesh at like through the semester. And first like earlier I figured out is like basically there's the bad like the mesh was not great enough, and then it caused so much problem with like sig fpe and like a delta kfs. The solution for this was like basically umc of mesh requirement like has about like 5 rules. So like all the buildings like touch xy ground plane, and then no floating intersecting geometries of course, and also the bottom face removed for all the buildings. And just like as a visual like triangle meshes, and also having couple simplified trees, even though like it's not part of my studies, because umcf has that vegetation meshes, I still put part of them. And basic like a geometry problem got figured out by using these requirement. However, like after those ever, still some kind of boundary, like a boundary edges, like a boundary mapping problem is still happening. And I've been documenting all the processes and then the error and what kind of configuration I've been using. But yes, I'm hoping I can keep developing and yeah, working on these cases for next semester. Yeah, that's all from me, and I'm gonna hand it to Malika for next.
Yeah, can you go to the first slide, please? Can you, Aiko, can you go to the first slide, please, for me? Yeah. So, this semester we have worked with UNCF, which is a Grasshopper plugin that simulates urban microclimate using computational fluid dynamics. It can simulate climatic data like temperature, wind velocity, humidity, surface temperature, and others alike in an urban setting. It is primarily a tool designed for architects and urban designers to help guide the design process better. Since it is in a primary stage, we worked on troubleshooting the plugin, testing and creating scripts where we developed a default template with different kind of geometric configurations, as you can see here, which can be loaded in the plugin so users don't have to generate a script from scratch every time. The three images here run a simulation for temperature in an urban setting, with red denoting heat islands and blue representing more shaded zones. As you can all see, All these have different results, aiding designers to guide their design process efficiently. Additionally, we have also worked upon updating documentation and tutorials for this plugin, which can be found on its website for better understanding and user acceptance. That's pretty much what we have worked on this for this semester.